This is where we left off in our last video. We have the vector function a is equal to 3xz squared I minus yzj plus zk. In our last video we found the divergence or the div of a. This time we want to find the curl of a. Alright? Now, we pointed out that in order to find the div, what we do is find the dot product of the grad and the function itself. This time we want to find the curl, so it's the cross product we're going to find now. Let me just erase these things to make the difference. It's nabla cross a. So nabla in this case, the divergence, right, is cross a. Nabla cross a. Nabla, as before, is I partial by partial x plus j partial by partial y plus k partial by partial z. And the vector function a, uppercase A, let me just put this here to show you a vector, right? If I was typing, it would be in bold. So the vector function is lowercase, right? Axi plus ayj plus azk, right? Now let's erase this because it's not the dot product we're looking at anymore. It's going to be the cross product. So now we have nabla cross a. Now remember, the cross product of a vector, right, is going to be a certain determinant. Here, the ijk, that's going to be in row 1, I, j, k, right? Row 1, give you the directions. Just a reminder, right, with vectors. Direction I, j, and k. Row 2 will be the coefficients of the vector on the left, the first one. If you say a cross b, then the coefficients in row 2 would be a. The a coefficients, if you say b cross a, then the coefficients in row 2 would be those from b. So nabla cross a, the coefficients of I, j, and k would be delta r partial with respect to x, partial with respect to y, partial by partial x, partial by partial y, partial by partial j, z I mean. Alright? And then row 3 will contain coefficients. And remember, when I say coefficients, I mean the coefficients of I, j, and k, right? The coefficients of the vector on the right. So in this case, the coefficients of a. So it would be ax, ay, az. Alright? Now, if you didn't remember how to find the determinant of a 3 by 3 matrix, you'll have to look that up. But let's just get that part out of the way. It's going to be I times the coefficients of partial with respect to y by AZ. So remember your AD minus BC with 2 by 2 matrix. So it's I, that minus. So you're going to cover the rows and columns that contains I, and then you find this this determinant, this 2 by 2 determinant within here. Alright? So it's I this times this minus this times this. It's going to be partial of AY by partial Z. Alright? And the minus, remember the place signs, minus J, so it's plus minus plus and so on. So with J you cover the coefficients, the rows and columns with J, and then you find the 2 by 2 matrix. I really shouldn't write it like this, you know. I'm skipping over the steps, but let me rewrite it. This would be partial by partial y, partial by partial z, ay, az. So that's what you see after you cover the rows and columns with I. The partial by partial y, partial by partial z, ay, az, right? That is the 2 by 2 matrix, the 2 by 2 determinant there. Minus, then when you cover the row and column with J, what do you see? You have partial by partial x, partial by partial z, then you have ax, az, then plus k times, so you cover the rows and columns with k, and then this is what you have. Alright? So what you see after you cover those things would be partial by partial x, partial by partial y, ax, ay. See that? Alright, so those are just points to remember. So what I want you to do now is to pause the video and go ahead and find the curl of A. Okay, you finished? Alright. Nice. Good work. Now let's work through the problem together. Here now, you have I partial by partial y, so it's going to be I, oh my, where I write t is I. What is the partial? What is the thing there, the determinant here? It's going to be this minus this. Alright, so it's this times this minus this times this. So it's going to be, well, I shouldn't bother to draw the lines here. It's going to be brackets now. So it's going to be partial by partial y of az minus partial by partial z of ay, okay, minus j, and after this going to be this time this minus this times this, right? Going to be partial by partial x of az minus, well, let me write the az closer, right, minus partial by partial z of ax plus k, and we have partial by partial x of ay minus partial by partial y of ax. Alright? So you see that. So now, let's see what's going to happen here. We have AX. We need to find the AX. Let's repeat this thing here. A is 3x z squared I. So let's just repeat it down here, rewrite it down here. A equals 3x what I said? 3x z squared I. 3x z squared I plus minus, that would be minus yzj. So we have yzj plus zk plus zk. All right, so you see that. Now the thing is, we need to do the necessary calculation here. All right. This look kind of messed up. Let me just do this. All right, so here now, this part, partial by partial y of AZ. Remember, we have AX, if you follow the pattern given by the equation, is AXI plus AYJ plus AZK. What is AX? AX is 3x z squared. What is AY? AY is negative YZ. And what is AZ? AZ is just Z. You see that? So now, the partial derivative of AZ, of the partial derivative, this one is AX. So we have AX is this, right? We have AX out here. All right, let's use AZ. So AZ, the partial of AZ with respect to Y. The partial of this with respect to Y is what? Well, Z would be just a constant. So it will be 0. All right. Now, the partial of AY with respect to by partial, well, Z. This should be partial AZ by partial Y. Now partial AY by partial Z is what? AY is negative YZ. So when you differentiate this with respect to Z, you get negative Y. Okay? What about this? What is the partial of AZ by partial X? Well, AZ is just Z, so the partial of that with respect to X would be 0. Alright? What about this one? The partial of AX with respect to Z would be what? AX is this, right? So when you differentiate this with respect to Z, you're going to have 2 times 3 is 6xz. Is just 6xz in that case. Now here, just checking something here. So you have a partial of that. So this is the original equation is 3xz squared I minus yzj plus zk. Alright. So here now, which one we did a while ago? Partial of AZ, which is, partial of AX with respect to Z, right? Is this one, the partial of X with respect to Z, by partial Z. What about partial AY by partial X? This one. Now, AY is what? So we're really finding the partial by partial X of negative YZ. But there's no X here, so this amounts to 0, right? And then finally, the partial of AX with respect to Y, or by partial Y. Partial of AX by partial Y, right? Remember, you're doing quite a bit of work here because you're finding the curl. And so you're finding, you have to find the determinant of a 3 by 3 matrix, which is indeed quite a lot of work to do, right? So this is much longer than finding the div. So partial of AX by partial Y is going to be the partial by partial Y of what? What is AX again? AX is 3xz squared. So it is 3xz squared. Now, when you differentiate this with respect to Y, you get 0. Okay? So now you can set up your equation. The curl is, right? And for the curl, could write back the nabla cross A to label it. Upside down triangle nabla cross A, that's the curl, is equal to. Now, what will happen here? It's going to be the partial of AZ with respect to Y, which is 0. So it is I times 0 minus partial of AY with respect to Z is negative Y minus negative Y, right? Minus J times partial of AZ with respect to X is 0 minus partial of AX with respect to Z is, what was it again? 6xz, right? And then plus K now, the partial of AY with respect to Z, what was it again? 0. So this is going to be 0 minus what? The partial of AX with respect to Y. Partial of AX with respect to Y. What was AX again? This. Partial of this was 0. So this disappears. 0 minus 0 is 0. Right? Alright, so what's going to happen here now is that you have nabla cross A. The curl is equal to, well, looks like it's going to be IY plus 6xz j. Oh, could just write this as yi then. Alright, so this is yi, since I'm putting the direction letters after. Yeah, look like that, is it? Alright, so that's it.